Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry Lesson 6-3 on proving quadrilaterals are parallelograms. We only have a few things to cover today, so let's go ahead and get started. First, I wanted to remind everyone of the properties of parallelograms that we've discussed so far. To begin with, opposite sides of a parallelogram are always parallel. So you can see that down here. The left and the right-hand side are parallel, and the top and the bottom are also parallel. Our second property is that opposite sides of a parallelogram are always congruent. So you'll see that here. Our left and our right are equal to each other, and our top and our bottom are also congruent to each other. Our third property is that opposite angles are congruent. So you can see that one here. E and G are congruent to each other, opposite angles, and F and H, the other pair of opposite angles, are also congruent to each other. Our next property is that consecutive angles are supplementary. So what that means is that over here, if you add a blue angle with a red angle, which are consecutive to each other or next to each other, they will always add up to 180 degrees. And then last, but certainly not least, in a parallelogram, the diagonals bisect each other. So you can see that down here as this diagonal is cut into two equal pieces, and this diagonal is cut into two equal pieces. So now, remembering what all of our properties are of parallelograms, there are 4 different ways that you can prove that a quadrilateral is a parallelogram. The first is by comparing the sides. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you can prove that the top and the bottom are congruent, and the left and the right are congruent, then that quadrilateral is a parallelogram. The second way that you can prove that is using the angles. If both pairs of opposite angles of a quadrilateral are congruent, so here, this one here, and this one here, if both of those are congruent, then that quadrilateral is a parallelogram. The third method is by using the diagonals. If the diagonals of a quadrilateral bisect each other, then that quadrilateral is a parallelogram. And the fourth and last way that you can prove that a quadrilateral is a parallelogram in this lesson is that if you have one pair of opposite sides of a quadrilateral that are both congruent and parallel, then you can prove that that quadrilateral is a parallelogram. So in this case, you don't need to have both pairs being congruent or both pairs being parallel. Instead, you need one pair of opposite sides that are both congruent and parallel. So let's go ahead and do a couple of the problems from your practice. This first one here says that there is not enough information given in the image below to prove that the quadrilateral is a parallelogram. So what they've given us is that one set of opposite angles is congruent, and that is not enough. You would need both sets of opposite angles congruent. So this is a true statement because it is not enough information. This next question asks us to use algebra to find the values for x and y for which the figure must be a parallelogram. So remembering that in order for it to be a parallelogram, you would have to have diagonals that bisect each other. That means that this side and this side of the diagonal would have to be congruent, and that this side and this side of this diagonal must also be congruent. So we can use that information to form equations and solve them with algebra. So to begin with, we'll start with the green diagonal here, and we would have 5x minus 4 equals 2x plus 14, and we can solve that with algebra. And what we'll get is that x equals 6. Then we can take this x equals 6 information, and we can plug it in to the blue diagonal, and what you'll get is that 6 has to equal 2y. So x has to equal 2y. And then we'll divide both sides by 2, and what we'll get is that y equals 3. And those are your two answers to this problem. So that's the answer to this question. And now we move on to the next one. Find the values for the variables to which a, b, c, d must be a parallelogram. Well, if it's a parallelogram, remember that the left-hand side here and the right-hand side here would have to be equal to each other. So you can set those equal. 3c minus 5 equals 2c plus 3. And then you can solve that using algebra. And what you'll get is that c equals 8. And then again, if this is a parallelogram, then this angle and this angle must be the same because these two lines here must be parallel and these two lines here must be parallel, which makes those alternate interior angles. So you set those equal to each other and solve as well. And what you'll get is that A equals 24 and C equals 8. And that's all for today. Good luck, everybody. I hope you guys do great.